enough with the introductions now. Let's start plotting some graphs here and plotting some points. I'm going to take my time on this. I want to really show you all the little details here in what it takes to draw a sine graph, and then in the next podcast, what it takes to draw a cosine graph. But I want to remind you of a couple things. Most importantly is that these are sinusoidal functions. And what does sinusoidal mean? Well, I know what you're thinking. You're probably thinking, oh, it's got to be a sine, so we're going to talk about the sine graphs here, Mr. Prema. No, we're not. We're talking sine or cosine graphs. Why? Because sinusoidal is short for something called sinusoids. Sinusoids, meaning that they exhibit wave-like patterns. And both sine and cosine exhibit these wave-like patterns. Aha! Okay, so that's why we refer to them both as sinusoidal, because cosine and sine give these wonderful wave-like patterns. Ta-da! Okay, so you learned something. Now, here's the thing that drives me crazy. When people start doing sinusoidal functions or sine graphs, and they have a table like values, like what you see in front of you here, is they go through each one of these. They go through the 0, the pi over 6, the pi, and they do this in order. Don't. Actually think about what you're after here. Think about the unit circle. Remember, when you're talking about the sine graphs, you're actually talking about the y-coordinates of the unit circle. So what easier coordinates could you possibly have than those quadrantial coordinates, which are right here, here, and here? You know what I'm talking about. This is the 1, 0, the 0, 1, the -1, 0, the 0, -1. And you know that that starts at 0, pi over 2, there's 2 pi over 2, which we call pi. There's 3 pi over 2, 4 pi over 2, which is basically 2 pi again, and we're back at the start. Now, think about this. You know and I know that this wonderful unit circle goes around here like this, and it comes back to this, right? Perfect. Look at the coordinates you have. You're dealing with the y-coordinate, start filling in the chart. So if you're dealing with 0, look what you got. It's 0. Okay, you're dealing with next pi over 2, it's a 1. So where's pi over 2? Oh, there it is, way over here. You're dealing with 1. And you say, well, what about those other 3 blanks there? We'll get back to it. Relax. Okay, here we go. Look, there's pi, which we're back to 0. The next one is going to be 3 pi over 2, which is right here. Oh, there's 3 pi over 2. That's at -1. Excellent. And then back to 2 pi, which means we're back to 0. And guess what? We're done. We're done with this section. And eventually what you're going to see is this. You won't have to graph much more than just that to really understand what the graph is doing, because you'll have the pattern. And remember, all of mathematics is a pattern. You just got to figure it out. What's our next step? Take a look. Our next one is pi over 6. Well, you know pi over 6 and pi over 3's go together. Absolutely. Those are those narrow little boxes. Remember the rectangular boxes that go like this. And you know that right here is root 3 over 2, 1/2. And this one up here is, 1/2. Almost messed that up. Here we go. 1/2. Root 3 over 2. And you know, and I know, every one of those guys starts with, of course, pi over 6 here. Then this one is going to be pi over 3. Now you see it, right? Absolutely. So remembering that we're dealing with the y-coordinate, pi over 6 is 1/2. Oh, okay. So that's right here. Now, check this out, because it's actually in order. The next one would be pi over 3, which is root 3 over 2. Look at that. Oh my goodness. So do all of the pi over 3's, pi over 6 ones here. So there's the next one, 2 pi over 3. Well, we got to be talking about this guy right here. Of course we are. And we know that that's root 3 over 2. Why? Because you're smart to put down add sugar to coffee, and you realize when we're talking about any of the coordinates here, we're always talking about a positive value for sine in this quadrant and this quadrant. Okay, let's go to 5 pi over 6. Well, wait a second. 5 pi over 6 is right here. Oh, look at that. That's 1/2. Then we go down to 0. That's nice. How about this guy? Well, after this guy, it's got to be 7 pi over 6. Of course. Now think about it though. Our coordinates right here are going to be negative root 3 over 2, -1/2. That follows the add sugar to coffee stuff, doesn't it? So this in fact is a -1/2. The next one is 4 pi over 3, which has got to be this one right here, which we know is going to be negative root 3 over 2. Okay. Next one has got to be 5 pi over 3, which is over here, still negative root 3 over 2. And finally, 11 pi over 6 right over here, which we still know because of add sugar to coffee, is got to be our negative 1/2. Oh my goodness, how beautiful is that? We only have one thing left to do, and we know our pi over 4s are right smack in the middle. They're right smack in the middle, and every one of these has got to be a root 2 over 2. So starting here, there's a root 2 over 2. Look at that. Here's another one over here, still positive root 2 over 2. Then, now that we've dealt with everything that's in this area as positive, we got to remember if we're going down in quadrant 3 and quadrant 4, we're going into the negatives. So there's our root 2 over 2, but we know that that's negative. There's our other root 2 over 2, and we know that that's negative. There's all of your beautiful points just plotted out for you. Now, if you're going to do a sine and cosine graph, does this mean I have to plot this whole table of values out again and again and again and again? No. No, it doesn't. Once you see the pattern, there's no reason to make an entire table of values here. It's actually kind of silly to do that, right? It's a waste of time because I want to show you something that's really cool. Let's start plotting these guys. I just happen to have a graph and axis right here. Now, I want you to go back and I want you to look at the values. I just happen to have them on a sheet out here that I'm not going to show you because it would cause me to go flipping back and forth all the time and make this a whole mess. So I'm just going to put the key values in. What were the key values? Let me show you what the key values were. Again, look at what the key values were. Look at that. Look at this. Look at this. Look at this. This is so neat. Oh, -1, 0, sorry. And then the last one, of course, which is 0, -1. The key values are here. There's 0, there's 1, there's 0, there's -1. So starting at 0 is 0. Starting at pi over 2. Where's pi over 2? Well, count it. 1, 2, 3, 4, 5, 6. So in the middle here, just like we have here, right smack in the middle between 0 and pi, look how that cuts it right in half. So that's where this comes in. There's right smack in the middle between 0 and pi. There's our pi, there's our 0. Right smack in the middle, we're at 1. So right here, I'm going to put a dot up to here. Then check this out. I'm going to go over to pi, which means I'm back at 0 again. Now, if you think about it, what's smack in the middle again? Well, there's our 3 pi over 2, right smack in the middle between pi and 2 pi. Oh, so between pi and 2 pi, 1, 2, 3, 4, 5, 6. Oh, 1, 2, 3, right smack in the middle. It's at -1, which is way the heck down here. Now, check this out. Do I have to put any of the other values in here? If you like. But what you're going to see is you're going to see a beautiful graph that starts up. And remember, it's a very curvy graph. Look at that curve this way, go down to here, down to pi, and then it cycles right back up to here like that. There it is. Now, if you don't believe me, check it out. Let's look at some of the values here. Do you remember some of the values? Do you remember pi over 6, which would be this value right here? That would be your pi over 6. Now, remember what pi over 6 was? Let's go back and check it out. Pi over 6 was in fact 1/2. So if I look over here, look at my graph. Pi over 6, look at that, 1/2. There it is. There you go. You see how it works? It actually works really, really nicely, doesn't it? Okay, so that's the point of all of this. Now, what's also cool about this is that let's make this pi over 6 1/2 about here, because after all, it's about 2.5. There it is. Okay, so moving right along then, look what happens when we go backwards. Think about this. If we go backwards from 2 pi and we go backwards going in this direction, aren't we in fact going over to the -1 then? So let's go right in the middle. 1, 2, 3, 4, 5, 6. Right in the middle, it'd be 1, 2, 3. Right in the middle, we'd be at, there it is. Now, how do we make sure that we're doing this right? We'll keep going. We went to here. We went all the way back to -pi. So we're now at -pi. But guess what? Our sign tells us we're 0. Look at this. So we're going to curve down here again and around about, and we're going to do this. Okay? Look how this pattern is developing. It's actually quite beautiful. Look at this. Going back here, now we're going back to, yep, That would be 3 pi over 2 in the negatives, wouldn't it? Well, negative 3 pi over 2 would be right in the middle between negative pi and 2 pi. So 1, 2, 3 pi over 2, there it is. At 1, there it is, all the way up here, and then back curving down. Notice that I didn't really care about any of the other points. I didn't. Why? Because they fall into place. Look, there's our pi over 6 again, and this time it'll be our negative pi over 6. At negative pi over 6, what are we doing at pi over 6? Well, at pi over 6, we know it's 1/2. At negative pi over 6, wouldn't that be the same as saying 11 pi over 6? You betcha. That's pi over 6 right there going in this direction. So it's got to be negative 1/2. Are we actually negative 1/2 on our table? Well, look, right smack in the middle. Look, look, look. 1, 2, 3, 4, 5. That would be 2.5, right smack in the middle. There's our negative 1/2. Look how this graph looks so incredibly beautiful, just based on very simple key points. This point, that point, that point, that point. Look how easy it is to graph these things if you're smart and you realize this entire thing is based on those quadrantial points. As long as you know what the pattern is, you can drive this wave as often as you like.